This is going to be kind of playtime, and brought along my models to illustrate what I'm doing.
Hold
on. In order so I can have a continuous flow with this presentation of this idea, if there's something you want to talk about, would you just note the slide number, and then we can come back to that and discuss that particular issue. Next. This is what I call what I'm doing. The SST is the geometry that I'm using and developed to explain, to work out the complexity of the structures. And then the idea is, once there's a working topology, geometry that makes sense in its own right, then apply it to the physical world and see if there's any correspondence. And that application is field structure theory. Next. I want to note this is a fractal universe that we're involved in here. All right, because this is a new paradigm, it will be necessary to establish a context, explain the language, and build concepts and constructs from scratch. But the paradigm has to relate to reason, and that requires that it relates to what is known. But what is known is the problem. After 100 years of unification effort, the problem is obviously systemic. It could be that our analytical tools are inadequate, and here I'll try to introduce a new one. Next slide. This is a hierarchy of emergent qualities. The assumption, nature is a hierarchy of emergent qualities. Nature is not anything, anywhere, and anytime. To study nature, we need a hierarchical developmental process that proceeds from emergent qualities. So nature is always, in my mind, a deterministic process. And the problem we have is that in looking at the continuum of structure, both to the larger and the smaller, from our human perspective, our little position on this broad spectrum, is that we can't be determinate beyond where uncertainty steps in and starts obliterating the evidence. So in order to go beyond either direction, we have to go to theory. And we developed our theory and tried to introduce first principles and then iterate it back up to a level at which we can make a confirmation of what we're doing in the empirical world that we can actually experience. So that's the process as I see it. Next. It stands to reason that the only thing we have to stand, and that's the only thing we have to stand on, that nature could not produce the determinacy we see at the human scale unless it started with determinacy at the emergent scale. So I fight the notion something emerges from nothing as if it was a cold, common cold. Next. Nature is a continuum going from simple to complex. And if you'll excuse me if I state these rather, what I consider totally obvious things, but it sets the stage for how we're building here. Each step introduces a new potential for complexity and articulation, i.e. waves to particles, to atoms, to molecules, to cells, to organisms, and as it builds. Each step must build on and include without removing that from which it is derived. That's the nature of a hierarchy. So high energy light gamma rays can morph into electron-positron pairs known to science. And when separated, should electrons and positrons meet, they decay back into, I lost the bottom part of that slide.
Yeah, well, the translation sometimes
does that.
I can try to get it smaller, but I think.
Okay, I'll just state it that it decays back into a clockwise and a counterclockwise gamma ray. So nature retains this memory of where it came from, even though it's morphed and deployed itself into higher structural forms. It retains the memory so that it can go back again when conditions necessitate to a simpler form where it can find stasis. Next. Uniformity comes from the many. From one comes the many. More assumptions. Nature gets simpler as it gets more fundamental. By that I mean the structure of a molecule is a complexity that is simplified in atoms. Atoms can be simplified into particles, waves, and then ultimately loops. A constant in nature means irreducible simplification at the emergent level. Constants are derivable from fundamental form. So what does fundamental form look like becomes the question. Now, I want to have you look, since this is a theory of structure, I want you to look at some really basic stuff. This is a tetrahedron. These are hinge points here. They're completely free to move if I hadn't put it in in a triangle. But even though these points are allowed to move, when it's in a triangle, this is rigid. If I were to add another stick and make a cube, everything moves. I've lost structural stability. And if I put in another stick, then it flops all over the place. If I build any polyhedra, any polygon or polyhedra, if there isn't some sort of tetrahedron or triangulation involved, it's going not to be stable. Now, why is that? Why is it when architects build these buildings, they have to be very mindful of where the tetrahedrons are or the triangles? If they're building a cube room, they've got to triangulate the space to keep it here. Otherwise, the whole thing collapses. Why are we limited to one structural form in this vast universe of seemingly infinite variety of form? How can nature structure any form, any polyhedron, and we're stuck with just the tetrahedron? Let's look at that. The answer is in the nature of fractals. And as we see in this illustration here, we have we start with a basic unit, and we put we make a fractal iteration of this. So this basic unit becomes a form that creates a larger version of the same image. So this is a fractal at the next scale up from this one. But we can't do that with a cube. If we put a cube at each face of this, a square rather, at each face, then we end up with a shape that does not look like the shape we started with. So this is not a structural fractal development. And it turns out that this is the only one that does that. You work with any polygon you want, and you'll never get you won't be able to reiterate that form at higher levels of complexity. And this has something to do with why that tetrahedron doesn't collapse and everything else does. But nature is amazing. So what it does is, instead of
Go ahead, you can get close.
Getting near the
Speak.
What it does is it always does things in pairs and in opposite pairs to achieve structure. Whereas the reason the tetrahedron is structural is that in the tetrahedron is another tetrahedron. So what it does here, in order to produce this, which has structure, is it puts another cube and skews it off so that it forms what I call a tetrarchy. In other words, it makes a tetrahedron, a triangular trestle about with it, and thereby that form is structural. Here's the cube. And when I put them together, this thing gets rigid again. And particularly if I made rotation points at these points here, this whole structure then becomes structural. So nature has figured out the way to make forms that aren't structural is to double them and skew them. So skew becomes an important fundamental principle that nature is using right from the beginning. Okay, let's move on to the next. That's a good one. Let's do another one. I didn't like that slide.
It's centering you.
I think I was going off on a tangent. Okay, so now let's look at how we are going to start from first principles and build a universe. And the simplest notion that I can think of is action. A acts to B, and B returns the visit. And when you put these together, you get an oscillation. And at this point, I'm calling this action because I want to clarify action as separate from energy. And then nature has also found that it's got a form working here, but it can do more if it puts it into a circular. Instead of an oscillation, we have a rotation. And without changing the direction of the arrows, we now have this whole thing spinning in one direction. Whereas here we were thinking in terms of two directions. And all we did was go from oscillation to rotation. Next. So we've got those first two qualities going. Then we add dimension. And dimension is these lines are now given a dimension. They have a thickness to them. And because of that, the entire production of what we're going to produce all have to be skewed. Next. So now we take that action loop that we had, which was going one way or the other way, do it either way, clockwise or counterclockwise. And now we want to do what nature does, is bring these two together into the same domain. And the only way it can do that is to take the axis of this form and put it on its surface so that these two forms share the same axis. And to do that, they have to helically wind around each other. So this is why in this way of thinking, waves wave. It's two opposite motions interacting in the same domain. So now we've set up a new situation where we've got nodes and we've got frequency. We've introduced the notion of frequency into our loops. This is where energy comes in, because energy is a measure of those frequencies times Planck's constant, which is the length of the loop. Okay, next slide. So going back and just reviewing here quickly, we establish action, the loop, we've given the loop dimension, and we've interact a counterclockwise and a clockwise loop to produce, in this interaction, the phenomena of energy. Next. Now, what you saw there, I see happening at the most fundamental level of physical existence. Call it the ether. I like the word plenum better, because plenum to me is background dependent, and ether, as I listen to it being discussed, is usually background independent. And there's a big difference of what would happen there. So we have a notion of what action event is and maybe looks like, and we've introduced the concept of action and interaction between events. Next. Emergent qualities. We got rotation and spin emerging from these interactions that we've done. We've developed the notion of space in that loop, and we have continuity and connectivity. So space is a linkage of loops. That's the way I'm looking at this. And here the word space, which is a loaded word, it can go every which way. I'm thinking in terms of the medium in which reality occurs is space, but it also has a structure. Space has a structure, and that structure are these loops at the Planck level that are all linked together into a three-dimensional solid, as it were. And a loop has Planck constant is a proportionality constant between energy of a photon and the frequency of its associated electromagnetic wave. This calibrates energy to be a fixed relationship between space and time. Next. And I also look upon this event, this fundamental event at the emergent level, as a Planck's moment. In other words, this is the shortest possible interval of time, and it's not divisible. FST presupposes a matrix of loops connected fractally into a hierarchical continuum that provides a substratum from which energy and mass evolve, and I call that plenum. That was the notation about independence. Next. So back again, starting again now with the loop wave as a closed continuum. Next. We find that two things happen right away. And these two things are, they are so fundamentally important. If we make our loops out of one length of string, for the better word, and I wish the string theorist was here, I'd really like to show them this, then there is going to be an odd number frequency. If you count the nodes, these always produce a single string woven together, always produces odd number. Two loops produces even numbers. There's an even number of nodes here. Next. And this sets up the whole stage for things to come. So odd and even frequencies would seem at this stage to be a simple development of form. What odd and even do is to establish two distinct families of structure that in the physical world become energy particles, bosons, and mass particles, fermions. Which is which and how. Next. If we look at taking two loops and linking them together, and this is simply sliding the loops into one space, and this has a frequency too, and then we start doing this. We start winding the loops around each other. That is the same as that, just adjusted differently. You see how these forms emerge, and the frequency is always going to be an even number as you build these. Next. Every single loop wave knots. That's a question. The answer is yes. And here's what I want to show you on that. This is a single loop. Can you see this?
Yeah, I'm zooming in.
Okay. Oh. This is a single loop, and here's where I glued it together, or melted it together. And if you count the nodes, it's going to have an odd number of nodes on it. Now, this is a loop that's in what I call the open position. Next slide. And this is a double loop. And if you can see here, I've welded two loops together here at those dark places. So this is two loops, and if you count the nodes here, they're going to be even in number. Okay, next. Now, we live in a three-dimensional world, and we haven't got to a three-dimensional world here. I've done nothing to describe three dimensions. I haven't defined a volume of space yet. So at this level, we're in one-dimensionality. And I want to show you how we go from here to a three-dimensional event. Next. Loop waves, i.e. knots, have two states, open and closed. So this is the open state, and the closed wave state compacts these nodes in as small a space as possible. Open and even loop waves handle the condensed state very differently, as we're going to see. Next. So here's the open knot. It's a single loop, and it's an open knot. And the energy is nicely dispersed throughout the entire wave. So this is a wave front, a classic wave. Now, next slide. Here's what happens when you condense the energy of this in terms of twist into, now that's a frequency 11, this is a frequency 17. I did more loops to show you more profoundly. This is the form you get. So in other words, I hold one thing and I start compacting the knot like this, and if I had 17 loops, we're going to end up with this structure. And I can open this out, I can just pull this right out again, and it's going to look like this. So we can go from the condensed state of energy to the open state. And let's look at some of the properties here. Next slide. What we have here is a high frequency gathering of energy along this line, and a low frequency moving in the opposite handedness this way. And I want you to think in terms of electromagnetic charges, how they organize themselves. Here we have a field, because I call these a field, surrounding an electrode field going this way. And you can visualize how this field is compacting, is controlling the electron, keeping it to a path. And then this field out here, what is this? What happens here? If you look at the structure of atom, where this really becomes apparent, is visualize a wave of energy. And go back one. A wave of energy encounters mass. It transfers its frequency to that mass structure, and it concentrates 99.98% of that energy in the nucleus, because the electron that's out here is only 1 over 1,836 units more energy is in that mass. And the way we've got to build in this architecture, the way to get this form into this form and organize so that all this form is in the mass of the structure is the next task. And when we collapse it, when we collapse this wave, we turn a photon wave into an electromagnetic event that's occurring at the nucleus of this form. All right, change next slide, next two slides. Okay, here's the open knot, and the red and yellow are where the two knots, to show the two knots. So this is the double knot. What I just showed you is the single knot, the single loop. And the double loop behaves completely differently. And this is really important. So here, when we condense this wave, something completely different happens. Let's do that. Next slide. This blows my mind. It's just so gorgeous. Here I do the same thing. I hold one thing and I condense all that energy, all those waves, all that twist into a tight a ball as I can, and I'll get this form here. And this form, this loop here, has no energy. And all of the wave energy is now concentrated on one loop with one rotation to it. This one's going clockwise, and this one is going counterclockwise. And here it is. Here's the double wave. And remember, I just took it and started condensing it like this. And there's the form that I get. Now, what better model could you have for what happens when energy impacts a mass, and that mass somehow, which is what we're going to explore, condenses that wave energy right into a locality in a domain that's at the center of this overall field. We had in this form here, there's no locality. It's just a totality. But when this is the wave particle collapse model, so when that wave encounters mass and joins that mass, that whole energy collapses into the mass itself. And this is added to the structures, which I'm going to be showing down here. Next slide. So there's your, again, because these are two loops, all 16 loops are now here. This is a 16 frequency knot. Okay, next. All right, now let's go back and look at something simple here. The string people, the open string people are really lost in space, because the problem with that is this knot can be removed and lost forever. The universe that I think we're working with here is the universe that has the knot inherently woven into the action loop. And what we are constantly mediating here is going from the open knot to the closed knot. Press it right down to there. This has locality. This is when we can say, well, there's something, and there it isn't. But if we really understood what was going on, we would see that every locality has a field about it. And here's the field. And we can distribute that field, that energy in this locality back over that entire field. And nature allows us to do this if we understand the hookup, the condensing mechanism, and the expansion mechanisms. Next. So here we have, well, this is what I was talking about. Here's the condensed state mass. This is the same amount of energy in the energy form and the kind of different waves that are created. And again, I want to point out that here, when we condense this, we generate three kinds of waves, three kinds of fields. This high energy field, this lower energy field at the opposite handedness, and the zero energy field that emerges from it. Okay, next slide. The mechanics of energy to mass conversion raises the question, how does radiant energy become mass energy? As for instance, when light joins an atom, it increases the energy and hence the mass of the atom. Or when the opposite process uses high energy gamma ray light to produce electron-positron pairs. Well, that was what I was just talking about, so I'm catching up. Okay, next. Playing around here with words. But the particle, what's the particle? And I'm saying that it's energy and mass organized in this way. To answer these questions, we have to look for some mechanism that will confine the wave nodes of the loop, of the wave loop, and compact them into a limited volumetric domain. And we've got to understand this process to understand the relationship between mass and energy. And that we're in a continuum here, but we're shifting properties. And there's a mechanism for why those properties shift. So FST has discovered that to do this, we have to tie a three-dimensional knot with one-dimensional loops. And to do this, we have to build a mechanism that will apply a compressive force to restrain the expansive urge of energy to universalize. One of the assumptions we're making here is that this is the state that nature wants to be in. But if it gets condensed and all the energy gets confined to one locality, and this is not prevented from returning to this state because of the phenomena of knotting, then we have a universal and persistent urge from nature that's trying to pull this structure apart. It wants to pull this condensation and distribute everything and put all this energy in equilibrium. And this is entropy. This is what we end up, the generalized effect being that of entropy. Next slide. So, building the particle mechanism. A loop defines a space, but not a tetrahedral space that has a 3D volume. Like, you can say this has kind of like some kind of inside-outside space, but not really. This is not really a definition of space. So how do we go from here to a spatial event? Next. This is the first development. This form is called an actor. And this actor is right-handed. And what I've done here is I've taken this loop. Now, here I've got the loop woven, but I just generalized it here because I'm using tubes, because I want something that has a tensile strength to it that resists bending. Now, if I take a loop and bend it, it wants to unbend and take the stress out and be a simple loop again, where all the energies are neutralized. There's no torsion in it. So I bend this yellow loop, this blue loop, and this violet loop, and I bend them roughly 90 degrees. And I put them together. I bring those three loops together, and I get this form. This is the actor. Now, afterwards, if you like, come up and study how, I don't know if you can see it, but this blue loop, for instance, wants to go that way to get back to a circle. And I've had to put a little ring around here to keep it from returning to stasis. And so this little ring is an artificiality. I mean, there's no rings like this in nature. But remember I said that nature does everything double. So if I take this clockwise loop, can you see how this is moving in a clockwise direction? And I put into this domain the opposite handedness, I get this structure here. Next slide. We'll come back to that. Go to the next slide. Here. I get this structure, which I call a nadi. These are, that's a Sanskrit word which means the same thing as what the structure does. And now here I've made this and left the loop in the form of rubber bands on this, because I want you to see what happens when I get rid of the rubber bands. Now, remember, on this one, where it's a single handedness structure, if I cut those rings, this is going to fly apart. But here I've got two. I got a right and left-handed set of three rings together. And when I cut it apart, nothing happens. By the way, the simple way to make these things, if you want to do it, is just study this. I just use rubber bands to hold the pieces together. It's easy to do with triangles, but if you try it with any other shape, and you're in for a nightmare trying to hold it all together. Okay, so there's a perfectly structural shape, and what's happening is the red ring is preventing the yellow ring from opening, and vice versa. Yellow prevents red from opening. And now I've done something that I haven't done with just simple loops, is I've defined a three-dimensional volume. This is the simplest enclosure of space, the tetrahedron inside of here. And I've done that with rings. We're still just talking about rings. Nothing else has been introduced. And that's one of the beauties that this whole system has for me, is that the only thing I'm ever using is a ring. And the things that you do with these rings build hierarchy and complexity as we go along. Now, as a form, this has defined a position in space. It's defined a spatial event, but it's still attached to a wave, and is still can be considered nothing but a wave. It's just waves interacting creates this standing stable event. All right, next move. So the Nadi, the form of the energy takes to define a stable standalone particle having volume. The Nadi introduces an important construct that we haven't seen before in anything I've talked about. And that construct I call reality. That is, it can be either a real particle or an antiparticle. And that is determined by which set of twisting sticks is on the outside. And in this case, the red sticks are outside of the white sticks. And that, the choice you make there pervades all the rest of what we're going to be doing in terms of building the universe. Because if you are a part of the red, the universe that's developed with red over white, then the structures that will later become mass structures are going to have this same kind of relationship. Okay, next. So the characteristics of by the way, this is the neutrino. And the neutrino is the transition between wave and a matter event. It's a matter event in terms of defining space, which is a prerequisite of matter. It's an energy event in that it is made from the interaction of light waves and retains the speed of light nature. You can't make an at-rest neutrino. These are speed of light particles. So what we're trying to get to is the formation of mass, which can have a rest state. They're stable and can have rest state as well, and define space. Next. So how does nature produce a particle that can be at rest? Nature interacts three of these. Now remember, each one of these is one of these. Each loop here is a pathway of this. So now we're going to interact three of these, moving speed of light particle, and we're going to see what happens. Next. This is what is produced. This is called a structure. And what happens here now is these loops are penetrating the internal space of two other loops. And now this, I don't know if you can see this, I don't know, but the red loop is trying to move, this stick is trying to go this way to resume its circular energy not a state devoid of energy. So it's blocked by these two circuits here. This stick here can't go that way because these two are blocking it. Whereas back here in the actor, it could go away because if that ring was removed, that would open. But here, the domains have been penetrated so that we can tie a knot. So this is a true three-dimensional knot. And in producing this has a structure. See, if I try to pull it apart here, when you get a chance, come up and feel the energies of this. You know, I try to move it apart and it will snap back together again. And another important thing to note, really important, is that this structure is stable with only one-handedness, whereas this structure had to have both-handedness in the same domain. But once this structure is able to weave this, then you only need one-handedness. And this is why spin for fermions is only a half, because this is half the picture. The other half would be the opposite-handedness, but it isn't needed here. So whereas a boson particle has got to have both. It's got to have both-handedness, and that's why it's a spin one particle. Next. Structure. The form or particle that occupies space, that can be at rest, and has mass is the fermion. Now, what do we mean by mass? We've had this discussion so many times at the dinner tables. Mass is, make it really simple. Got that one? Mass is the effort it takes to move this knot along this line. Like I can keep feeding this along here. And if I had another knot here and brought these together, one is going to resist the other. In other words, when I bring that knot down, they're going to collide with each other. And so the resistance to transition is an aspect of mass. And in order to move mass, one has to change the frequency of the structure for a mass to move. That's why you got to add energy to a mass in order to make it move. And what you're doing is you're changing the frequency so that now it has a new orbit. And all movements are really the necessity for a mass to move to a higher or lower orbit, higher or lower frequency. Because the frequency on here is determined, the length of this line is determined by the frequency. Because as we've seen in Planck's constant, F times h, if we change frequency, we change the dynamics of that energy event. And it has to, since h is fixed, it has to occupy a bigger or smaller event if we change that number. And what that means is that this knot has to add more loops to it. Next. So here's a comparison of an energy structure and a mass structure, and you can see how these loops are knotted together, and these are just held together by a linkage. And that this form is going to open. But this form is what is inside of these forms. There's something coming up here I can't wait to show you. Next. Okay, now remember I said that the structure for matter, this is a structure, only needs one-handedness to be self-sustaining and stable. But let's put the other handedness in there and see what we got. And that is, whoop, did I forget to bring it? Anyway, there's a picture of it. I guess I forgot to bring it. Oh, here it is.
Easier to carry.
There it is. I don't sequence.
It's in disguise.
This is your right and left-handed structure. Now that form right there. And again, you see that in order to build this, you have to choose one-handedness to be outside of the other-handedness. And you can do it either way, but no matter how you build it, one is going to be outside, one's going to be inside, and that becomes a big issue. That's the issue of cloaking. And what field structures are telling me is that all of the antimatter in this universe is right here. And it's inside, cloaked by the real matter. Because we happen to be observing the outside energy forms. And inside are the anti-mirror image forms. And is there evidence for that? What happens when a neutron decays? Out pops an antiparticle. It didn't pop out from nowhere. It was in there all the time. And furthermore, this form here, the regular, what we think we're seeing, the structure without its counterpart. We think we're seeing this, but what is actually there is this. What happens is that you got to remember that in this tube here, in this orbit, is not a single loop, but this, a double loop. And the double loops are bosons. So as this clump of energy is confined to the inside of this form, the nuclear center of this form, this energy is trapped in there by the interaction of the fields at the vortexes, at these points. This is like a guitar. When you move your finger down and twang it, all of the vibration is below your finger, and this is where the finger is. This is nature's fingers here, keeping all of this vibrating and going on in here. And as you change the geometry of the polyhedra, you're changing the frequency. And I'll be showing you that just next here. Next. So cloaking is an important concept in this configuration. And I'm just restating what I already said. Okay, next.
Don, I'm sorry, I still don't understand what cloaking means.
Cloaking means
Is that holding the finger down? Is that what cloaking means?
Cloaking means that the handedness of matter that we're seeing we're seeing it only because we too are operating from that particular handedness of matter. So, and that matter, called real matter, is obscuring the antimatter inside of its structure.
So could we say cloaking is sort of making a black box out of things inside? No.
I'll play with that. The problem with black, it symbolizes absence, but there's no absence here.
I understand.
Yeah. And so, in order for this form to exist, in order for it to carry a wave, remember a wave has to be an interaction of opposite chiral motions. That's what causes waves to wave. That's what causes these loops and these structures to vibrate, is that we put opposites together. They attract. Next slide. Wait a minute. Right, okay, next. Now, so the structures can be any polyhedra simply by circuiting the vortices together. And the frequency of the structure is determined by the polyhedron, that's an important concept. And each polyhedron modulates the loop to have its own unique set of frequencies. this is how FST understands spectral analysis and why each atom has its own vibratory signature. All other frequencies are not needed by the form are rejected, while those that are needed by the form are kept. Now, for instance, in this structure, if energy is brought into it and brought through here, the only energy that's going to be taken by the structure is one that has the same frequency as these loops. And these loops are two frequency loops. It's a very simple form here. All the others are going to be not accepted and rejected, and we'll see in spectral analysis that here's the shadow line because that structure took those frequencies and gave away all the others. And that's how we identify all the particles. Next. And this shows you how any polyhedra can circuit these action loops. And each one creates its own unique frequency signature. So here's an octahedron. And if you look at this, you'll find that there are four loops with 3 frequencies each. And the cube is 4 loops with four frequency. In other words, this wave has four nodes in it that you go around here. There's 4 of the loops in here. So if you know the polyhedra that's at the nuclear origin of this structure, then you know the frequency of the structure, and vice versa. If you know frequency, then you know what polyhedra you're dealing with. This introduces the idea that now we can have determinacy in a structure that we previously could not understand in terms of the movement of energy in that structure. And I won't go into that. Okay, next. What happens when structures interact, as do actors and nadies? When structures interact, something new and completely unexpected happens. At least it was to me. The structure assembled fractal hierarchies that we call atoms. In FST, atoms are structures inside of structures, or what is called, next slide, the superstructure. And I can't tell you what fun it is to find these forms. It's just thrilling. So here we have a tetrahedron, and I built a tetrahedron larger around it, and then instead of circuiting the tetrahedron to itself, as I did here, I circuited to the one outside, and I end up with this configuration here, where now I have a nuclear event, which I call the mass field, and this is where all that energy is being concentrated. And it's kept out by these points of interaction here that suppress the energy from getting out. And the remaining loop goes out and connects with a larger event and builds the energy field around this structure. So I have a white mass field surrounded by now a structured energy field. In other words, it's got a tetrahedron form out there, whereas in this form, the field was yet defining another field. So in an atom, we have the nucleus surrounded by this energy field, and these points of interaction out here, we're calling electrons. And what is, let's see, let me go to the next slide. These are other views of superstructures. Next view, next slide. These are superstructures with both handedness in them, which is the real picture. this superstructure only has one-handedness in it. So the antiparticle isn't in here. So here's where I put the antiparticle in. And that would be this form here. And you need to look at this closely to appreciate what's happening. But I really like how the energy twists around itself as it comes out to recirculate. And you get this idea of charge bundles developing in this form.
Does that form represent anything physically?
Yeah, this would be, this could be a atom having 4 protons in it.
So a helium atom?
Yeah.
That's a helium atom.
Yeah. Now, let's go to the next slide. Okay, it's just a statement. Next. It should be loading
No, I can't.
a little animated movie.
We can't do that. If you want me to go off, it will take about a minute and a half. The people on the internet will see it, but that's no problem. I mean, it's up to you.
Well, let's come back to it.
Okay.
I'll show it at the end.
Okay.
Figure out time. What that was showing was I built a small little nucleus in a large tetrahedron inside, outside that small nucleus, and then I connected the circuits. And what you get is these winding bundles of what would be electron bundles coming out and circuiting around this form. And you really get the impression of the way a ball lightning must be, or even the lightning between clouds and Earth, that you have in this nucleus an abundance of action, and you're going to redistribute it out into this field. Okay, next. So, what it boils down to, pretty simple, that if you want to account for mass and energy, it turns out that in this mode of accounting, mass is the number of loops. See, this is one continuous loop going around here. And energy is the number of times those loops are twisted, that rotate in their journey. So to give account of the energy, you count the number of twists. And to account for the mass of the particle, you give the number of its loops. And that's why mc squared, there's a fixed relationship between the mass, number of loops, and the energy in the form of c squared. It's the mass squared gives you the loop number. And that's why the energy of particles are not continuous but occur in jumps, because they have to, if you're gonna have one loop, then you've got to square that number of loops to get the energy number. So it has a not a continuous progression, but one that moves it in a square. Okay, next slide. So let's do the arithmetic on, since I've said that this is the form of mass, structures in mass have this form. Let's work with that. Okay, next. Now, jumping here, putting up the number 2187. Before asking what this number means, let's ask, what does this number look like? Next. Right. It's the fractal. If you count each line in the structure, there will be 2,187. Now, this is bookkeeping FST style. And what I'm trying to do is to account for the mass values of the known particles and see how we come out. So next. So if I start with one loop, then I build two loops, well, there are two loops. Then I build three loops, and three loops gives me, this structure has three loops. So then I take one loop, I take two and put them together to make this form. And then I use that as my fractal increment, and I make this form. But notice that these inner triangles are superimposed in the center. So what I'm doing, in a way of a notation, is darkening in the center, which means that I have more than one loop in there interacting at the nuclear center, because I'm now building something like this, where I'm loading loops into the center. I'm loading loops into the center by adding more sticks in here. And so the progression is multiplying itself by 3 each time I make a fractal iteration. These 3 here become that, and you count the loops up and you get 81. And then that is these 3 loops put together to make 243. Next slide. And then, so all of that before is up here. And then I add the fractals, and I build this fractal, and I get 2,187. Next. And that's loops. Now, why is this number important? Okay, let's look at it. This turns out to be the mass number of a neutron in its natural hierarchical structure, which is in the atom. Neutrons don't form outside of atoms. They form in that mass event. If you take a neutron, which will last forever, outside, it starts flying apart. It takes about 15 minutes to do it. Yeah. Now, what happens? This pion meson leaves, and you end up with 1,944 units, 44 loops. And then you take 81 units off, which is another level of the fractal. By the way, here it is here. You want to study up close, but no one can see this from back there. But the 81 level is here. There's 81 in that section right up there. Then you take out 27 units, and that is the mass value of the anti-neutrino, and you end up with 1,836 units of electron mass in the proton. This is the proton you end up with. And this is why the fact that this number is a decay product of this, and that in a mass, the energy is amplified. And when you take particles out, only the electron and the proton are stable, and all the others are going to lose mass to get back to those shapes, to those degrees of complexity. And I'm not satisfied with the answers of why 1 and 1836 are the stable numbers. But I don't think I'm going to get that answer until I actually build this thing. And it's going to be huge. It's going to take a while.
This number is not at all exactly 1/18.
Right, there's a fraction.
Yeah.
There's a fraction. That fraction is in what happens before unit 1, which, remember, is the end product of all the other developments until you get to that structure form. You have these actors, you have the neutrino, and those structures come before you actually get to the electron in terms of complexity. Next slide. So what I've done just for fun here is I've taken off the missing part of the neutron, and this is what's left to make the proton. And then I condense this into, next slide. I condensed it into these, and talked about that before, how we condense the energy of the wave to a location on the wave. And another thing I like about this model is that if you break the energy loop, the mass loop will not be broken. It simply will be without its energy field loop. The proton can exist without the electron, but it prefers to have an electron. In other words, here I have two loops, and I've got one loop concentrated here. And if you imagine this is in here, computer animation would be wonderful to be able to do these things and show how I'm getting each stick here is going to be looking like this in here. That when you break this bond here, what happens is this wave now resumes, spreads back over its chiral opposite, and then propagates as a bound wave. Next. So we can go to mass to energy without doing anything but altering the configuration that these are taking. Proton without its antiparticle, the antiproton, cannot carry energy. Hence, it cannot exist. With its electron, the proton doesn't need its antiparticle because the electron is providing the surface around which the proton loops. This is providing the wrapping wave that occurs in order to produce this. But if I remove this other loop, then this can exist as that, independent of this, if I were to cut it out. But it would open up. The reason it doesn't open up is because the opposite anti-proton is also wrapped there, going the other way, and it's going to keep that form stable, like is shown here. So in other words, you can't separate these two chiral fields or particles, whatever you want to call them, because they are keeping each other localized. And okay, next slide. The atom has a huge energy field compared to its mass field. When fermion energy, odd number loops, condense, the length of the loop gets longer, hence the volume of the wave increases. In other words, I'm working here on why is the electron, the proton, so tiny compared to the energy field of the electron. And if we begin with the notion that this wave is being condensed, that means we're condensing an enormous number of nodes into that proton. And the proton energy must be a very great, much larger number than the electron energy. So I'm coming up with that to show you what the differences are. All right, next. This is what I was just saying. Remember, bosons are two loops there. Next. Okay. This is kind of neat. If you take a simple knot, and you take 3 of these, and you count the number of loops in these knots, it has a form that it takes when it goes together. And remember, this loop is the same as that loop, only that's the open, and that's the closed, semi-closed. So you put these 3 together, and you preserve your loopness while you concentrate the energy and integrate it together at the nuclear event. Next. And you can build all kinds of beautiful, almost Arabian kind of configurations of non-integrations. So in the chart, the green and white is referring back to this model here, green and white. You find that as the loops increase, the energy, which is the number of times those loops are twisted, is squaring each time. And that's the fixed relationship between mass and energy, m and c squared. And yc is squared in this terms. So while we have 27 loops, we're getting 729 twists altogether. So when you end up with the neutron, you've got this many loops, and you've got this is the number of twists, 4,782 twists. And what you're doing in a particle is you're condensing all of those twists to that nucleus, which means the wave that supported those twists is getting huge. And what needs to be determined yet is exactly, and I've heard some indications on the math of that for this group here, which I'm going to go home and work on, but the volume relation of twist to space. But it is a known fact that the neutron has 6 powers more energy than the electron. And this is where that's coming from. Next. So when you put this together in terms of the known particles, here's what we did with the neutron. And we took out those 3 particles, which we know depart, and we end up with that. And this is the ETA and the koan and the pi, and these are the decay schemes, the particles that are generated off. And so I did that with each level, and notice that the first 6 levels are all the different electron shell states, energy states of the electron. And what we're calling, like this state here, when separate from the electron, is the energy value I gave the neutrino. So the decay schemes here seem to be working out in terms of these are the known mass values of these particles in electron mass units. This is just copied out of the book. And these are the number of loops that do that. Okay, next. So looking at electron shells, these are your different shells and the different number of electrons that could be in them. And this is the number of loops that it takes to make these different forms. Okay, next. Loop to line relation. In other words, this is giving us the energy number on these different electron shells, and adding up the number of particle electrons in there, the loops, and that's the energy. Okay, next. Previous chart is noteworthy because that the proton is 6 powers more energetic than the electron, and field structure, fractal architecture explains why. Okay, next. We're almost done. Now, I wanted to mention how it's kind of obvious how this relates to string theory. And the problem, as I see it with string theory, is that they've got a problem where they have an estimated 10 to the 500th power number of ways a string can vibrate, and no way to determine which ones are the ones nature wants to make particles. And what I'm showing is that nature determines which ones it wants by interacting these strings. Now, these are closed strings, not open strings, about a nuclear event, so it creates a polyhedron in here. This polyhedron is what telling that string how it wants it to vibrate to form this form. So we found a mechanism for domesticating the wildness of these strings. And it's only going to allow a certain vibration for each polyhedra that we put in the nucleus. And this polyhedra can be immensely complex, as we see in a uranium atom. You know, instead of 6 sticks in here, there may be 6 million. And they're going to be connected to all of these other shells. Okay. And so I think the string theorists are on at least the loop string theorist people are really on the right track. They just need to understand structure and how these strings get the form that they need in order to be self-sustaining events. Next.
Are we getting toward the end?
Okay. I've mentioned what that is. Oh, this is a project that I think it is possible to build an atom at the human scale, centimeter or 2. And the reason is that this is a theory of structure, and it says if you can gather the energy needed to build this structural hierarchy, then you can replicate any form of structure at any other scale if you can get that energy together. And it's been possible recently to build electron rings, and a fellow named Clint Seward has produced rings that last almost a second, which is a very long time in electron life. And what I'm suggesting is that if you knew how to interact those rings, you could build atoms at this scale. If you did that, think of what could happen. You've got the ultimate battery.
Yep.
You can store immense amounts of energy, tiny little spaces, and because it's an atom, it will stay there. An atom is a lifetime, universal lifetime event, unless it's acted on. So I would like to be a part of a project that would attempt to build the macro atom. Because if we did build that, it would prove field structure theory as a valid theory to use. Got an ulterior motive there. But as far as solving our energy problems, it's all in electricity. How do we store electricity? Everything stumbles on that issue. So if we get off of the molecular paradigm and into the atomic paradigm for storing energy, then we're going to solve our electrical problems, I think. Next. I won't summarize. Next. These are my great people. You know, they've been with me on this throughout, and prostrations to every one of them. Thank you very much.
This is so deep that I think this is going to go on for years and years with commentary, but I see one particularly eager one there.
Oh, well, what I really want to do, Don, is I want to go through the whole presentation again, just so you need, so I can stop and ask questions on every slide.
Yeah, I know.
I'm itching. But I tell you what I'm most itching to do is I really want to put numbers to this, not just
That's
the numbers.
right.
No, but you're just doing integers. What I want to do
I'm
is
so
I want to put
superficial on the
electrodynamic
numbers.
numbers to this, because stability demands that the field, the electric field, the flow field, and the magnetic field are all perpendicular. That's the definition of stability at all points in
Right,
space.
I agree.
And I want to take the simplest one first and see if that's the case. And I believe that the reason why the numbers like 1836 is not an integer, the proton electron, is because you have to take into account the finiteness of the loops themselves, which also have structure. We have to keep
Right.
going, all breaking it down,
Yeah,
and that's where those weird numbers come from.
Right,
And
right.
somewhere in there's the reason why they are what they are, and I
Exactly.
believe you're very close. I'm
Yeah.
excited about it. So let's go
Great.
together.
Wonderful.
Okay, Warfield is exploding too.
Yeah. Do your models match the quantum configurations of atoms?
Yes, I didn't get a chance to show you that, but take a look at what happens here. If you take this structure, which is the a matter structure with both clockwise and counterclockwise circuits. Call it a proton if you want. And instead of connecting white stick to white stick, you connect white stick to blue stick. Like you follow that circuit around and it goes here, it connects to a white stick. In other words, you reverse polarity in your circuitry. This structure here collapses into this structure. And this is a very familiar atomic structure. Methane has this form, among others. And so by manipulating the circuitry, these forms morph into these shapes that you're seeing.
So they match pretty close, all of them?
You can replicate all of them.
Wow.
All you have to do is get the right tetrahedron, the right polyhedron, nuclear, and the right number of circuits, and then work with how you circuit them together.
That's impressive.
Yeah.